Okay. I know some of y'all are still doing reflections, so I'm not going to do anything new. But, man, I better remember to turn this off. I'm forgetting. All right. So keep doing your reflections. Remember, I just want you to do that week 3 reflection if you haven't yet. I was missing 9 of those. And then a quick reflection about how prepared you felt you were for the test. Did anything catch you off guard? One thing you could have done better to prepare, one thing I could have done better to help you prepare. Yeah, did I give it back to you yesterday, though? You don't think so? So then you grab turn it down. Okay. Let's do this. Once you have your stuff done, turn in your reflection right here, the week 3 reflection, and then your test reflection right there. You haven't taken the test yet, so no. Yeah, if you haven't taken the test yet, we have a couple of us who haven't had a chance to take the test. No, please make sure your name's on it, because again, I'm trying to understand and help support you better. Yes, ma'am. That was last Friday. I passed out at the end of class last Friday. Sure? Yeah.
You started pressing on record yet?
I already did.
Oh.
What'd you do? What sketchy thing you doing?
I didn't do nothing. I just walked in front of the camera. I don't want to be in your video.
Oh, I'm so sorry. For the reflection?
Can I scoop my dress back over?
Yeah, I had to move this. Get out. All right. Yeah, so while y'all are finishing up those reflections, and who was it to me that you still needed a reflection, right? While y'all are finishing that up, agenda, we're going to start and focus on that task that I shared with you called to use or not to use algebra. It is based on an actual set of tasks that I have, but we're just going to share it verbally. And Mr. Hobby passed out a prayer model for you to take notes about it later. Okay? We good? Okay. So, focus is on mathematical representations. As a quick recap, what are the mathematical representations? How can we represent mathematical ideas? With graphs. Graphs. So graphical representations, tables. Okay. Words. Okay. And algebra. There we go. So algebra here. So just be aware, like the words I put up here are the adjective form of each of those. A graphical representation, an algebraic representation, verbal. If you can just say graph, table, algebra, picture, words, I'm fine with that, but I'm going to try to use that more precise vocabulary with it. And again, that's the adjective form of each of those terms. So those are the different ways that you can create and represent mathematical ideas, and that's going to be important for today and honestly the rest of this year. So objectives, right? Create and use mathematical representations to find the answer to posed problems, and then solve algebraic representations of a posed problem. Okay? And so I told you we're going to solve each of the following 3 problems in at least 2 ways. We're going to present solution methods. Again, this is why it's great to have vertical representations, or vertical surfaces. That thing. Hey, good morning. Come on in. Thank you. All right. So, what was I going to say with this? What was the task I started yesterday? What was the story? we have a what?
Good morning.
Bottle and a cork, right? So bottle and cork. What do we know about that bottle and cork? So weigh 315 pounds, right? 315 grams total. And then what was the other detail? So the bottle weighs what? 300 grams more than. I would say, I don't think I told you it was 300 grams. 300 grams more than the cork. You got two requirements to find what the weight of the bottle and the cork are, right? So the bottle and the cork together weigh 315 grams, but the bottle weighs 300 grams more than the cork. And so you have to do at least two things. What are those two things? You have to solve this using algebra, there we go, and what? Say common sense? Do you have to use a picture? Or a graph? Or a table? Or you can just use your words, right? Like if you can logic it out. So my point is you need to solve it algebraically, yes, but that doesn't necessarily mean you have to do it algebraically first. Maybe you choose to do a graph first, or maybe you choose to do a table first. And so I asked you yesterday to start developing some strategy here, right? Okay. If you have not finished your reflection, put those reflections up here. Once you are done with your reflections, I want you to go to your vertical surfaces and let's tackle this problem. I'm going to come around and support. Mr. Javi will come around and support as well. But let's try to figure out how much the bottle and the cork individually weigh.
I think you can get out, maybe.
It's not.
Reminder, okay? When I talk about this problem, I want us to pay attention to the language, because the language here explains a whole lot. And when we talk about mathematics later, the language is going to explain a whole lot. So I'm going to talk through some ideas. Remember, I'm going to write in purple on white boards, and I'm going to write in blue on the chalkboards. Pay attention to how I'm annotating things, because I'm going to talk about some really fundamental details that can be a game changer when we start to understand it later. Okay, so first things first, a lot of us kind of just did this in a thinking way. Those of us who found the answers first kind of just figured it out, right? Landon did some magic math that left his group thinking, what? Right? So let's formalize this. Let's make sure we understand this, learn from it, ask questions. By the way, as I'm consolidating, ask questions if you're stuck on something or if it's not making sense. But what I want to look at first is this detail right here. The very first note was that the bottle and cork weigh 315 grams total, or together. And when I hear that language in mathematics, what operation should I be thinking about? Addition. But I told you that the bottle weighs 300 grams more than the cork, and that's not what this said, but Miles said that means their difference is 300, right? If the bottle weighs 300 grams more than the cork, then their difference is how much? 300. And when we hear that word difference, we hear subtraction. Okay? And so there's two major methods we could have used here. And I'm going to show this one first, because I don't know, a lot of us got close to this one, but then didn't quite use it. So the bottle, and notice what variables you're used to using. X and Y, but do those always make sense in the context of a problem? No, right? We're talking about bottles and corks, right? So bottle plus cork, together they weigh how much? 315. Based on the way Miles was talking about it, what should I do now? Their what? Their difference, we're going to what? What am I subtracting? The difference between what? So what am I subtracting? Oh, the difference between the bottle and the cork is what?
300.
300. That's a method that we could have used here. All right. Now, hopefully this triggers something in some of us. By the way, does anyone know what branch of math we call this thing where we have more than one equation and more than one variable? It's a what? It's a system of equations. Notice literally, how many equations do we have? 2. How many variables do we have? You know, if I have 2 variables, you know how many equations I have to have? 2. If I had 5 variables, you know how many equations I'd have to have? 5, right? So, I'm not going to ever make you do that, so don't stress it. But we want to recognize it's a system of equations, and so when we have a system of equations, we have a few methods to solve this system, okay? What method would be most efficient here? And I know a lot of us use, what was the method a lot of us used? It started with an S. Substitution, right? I would not use substitution here. What would I do in this case? Not sure? Well, let's look at this. What if I add these 2 equations? What's b plus b? 2b, sweet. What is c plus a negative c, or just c minus c? It's what? Cancels, it creates a 0. It's almost like we eliminated that variable, so we might call it the elimination method. When we eliminate a variable, it's just called the what? Oh, elimination method, there we go, woo! And then what's 315 plus 300?
660.
Okay. Now, I'm going to go ahead and tell you this. Hear me very clearly. I cannot emphasize this enough. What I'm about to emphasize, you're going to look at me like I'm crazy for encouraging this method until we start studying exponential functions, and then you're like, oh, this is why Mr. Kinney recommends this. Okay? So, I understand. I'm crazy, but I also know it's coming up. Most of us are going to do what right here to solve this equation? We're going to divide by 2, okay? However, I'm going to write up here so it's easier to see. I agree, because what is 2 divided by 2?
1.
The 2 divided by 2 is just 1. But what I'm going to do is I'm going to use the reciprocal. Understanding this reciprocal is going to help you a ton later on in math. I'm not going to count it wrong if you don't do this, but I promise you right here and right now, 1, I'm going to always use the reciprocal, and 2, it's going to make your life easier long term. And what I mean by reciprocal, what is 2 understood to be divided by originally? It's originally just divided by 1. So what did I do to that fraction? Just flipped it. But here's why. Whenever you multiply reciprocals, they instantly create 1. Reciprocals always do that. So, 2 things. So, for example, if you had this, instead of dividing by 3/2, because that'd be an ugly fraction, you can just multiply by 2/3. I'm going to erase this because I don't want you stressing about this right now, but notice, what is 2 divided by 2? 1. What is 3 divided by 3?
1.
So using the reciprocal from the beginning and training yourself to use the reciprocal is going to make life easier later. So there's things I know, and you can be like, Mr. Kinney, but I could just divide. Yes, but I also know where we're going, and this is going to help you a lot if you practice using that reciprocal. All right, now, I talked about this with groups 4 and 10. So Kelly, why did I do it on the left-hand side? Why didn't I do it on the right-hand side? At least yet. You know how to explain it? Okay. Does someone from the 4s and 10s remember how I explained it? That's true. An event, but like notice I haven't done it to the other side yet. So why did I do it this side first and not this side? So I actually need to cancel it out, and I need to get the b by itself. So I'm not doing stuff on the right-hand side yet. What I'm doing is I'm trying to get b on its own. And so it's important mathematically to understand the order that things are happening. I'm creating a 1 so that I create 1b. But, and so I know some of us have heard, hey, you move it to the other side. That's not what's happening. I'm making a 1. And whatever I do to one side of the equation, whatever I do to one side of the equation, I gotta do to the other side. Does anyone know what that's called, by the way? There's a language for that. I know. Oh no, have we not heard this term? If any of y'all had Miss Williams in middle school, she's going to be heartbroken to hear you don't remember properties of equality, because I know she teaches it. Properties of equality, whatever you do to one side, you have to do it to the other side. And notice, is that the same answer we got for the bottle? So it's a different method, okay? But the reason why we have to do that is, does this equation here and this equation here look exactly the same? Does it? I got a 2b here and I got a 1b here. I got a 615 and a 307.5. So do they look exactly the same?
Yes.
Guys, how many b's? How many b's? 2. Are those the same? No, they're not. But do they mean the same thing? Do these two equations tell the same story? That's what I want us to understand. When we say a property of equality, those jokers may look different, but they're telling the same story. That's called equivalence. When we talk about equivalent functions later, that's going to matter. And again, I'm dumping a whole lot of vocabulary on you. I'm going to give you a lot of time to adjust and understand it over the next 2 to 3 weeks, okay? But equivalency there. Now, that's in contrast to this method, right? This is another way to do it algebraically. B plus C is equal to 315. We already addressed that, right? I talked about this with this group, and I don't know what happened to this note.
Oh, it's back.
It's the
on
previous
other
page.
Oh, thank you. All right, perfect. So, what did I talk about with this group up here, with this section?
The bottle weighs and the weighs.
So
it's like-
Why did I circle that word weighs, though?
Because it turns into an equal sign.
When you see a verb in mathematics, more often than not, that verb becomes an equal sign. Okay? Notice, right here, the bottle is equal to the cork, but plus 300 because it weighs 300 more. And so this is what a lot of us did from this point. We used what method? Like, how did we go from here to here? If the bottle is equal to this, I can substitute in. Right? If the C plus 300 is equal to the bottle, then I substitute that equation in. Well, sorry. I substitute this in for B. So for those of y'all who didn't get to that point, notice C plus 300 is taking the place of B because they are equivalent. They are equal. Notice, again here, same exact idea, right? But I simplify. I do want to point this out because I saw this in, actually I'll talk about it when I get over there. Do notice we subtracted by 300 here, making what? 0, right? So I want us to notice we're not just canceling it out, we're creating a 0. Just like here, what's 2 divided by 2? 1. Right? I'm not just canceling things out, I'm creating zeros and ones. Those are called identities. So cork is equal to 7.5. And what is 7.5 plus 300? 307.5. Right? So substitution here. That's a method to solve a system of equations. I think that's all I want to talk about from this one. So again, please pay attention to these annotations. I'll leave these up here when you do some notes. That's a lot of what a lot of us did. 2 major sections I want to point out. What method did this group do as their second? Actually, I think it was their third. They did a table. You know what tables are great for? Talked about this with a group of 2s early on. It helps you what?
Organized.
Organize, right? Guess and check, find patterns, right? So guess and check, find patterns. And so notice, if you just start out, and I think Miles talked about this with his group, originally you were talking about like 315, right? And so maybe you start there. And there's bottle plus cork, but also we talked about this earlier, if I check it, I also need bottle minus cork. And if I do 315, that works for here, doesn't it? But what's 300 minus 15? So does that work now? 305 plus 5. That adds up to 310. That would have worked for my difference. but not here, right? And so they kind of guess and check to get into the center here and get closer and closer until we get to this point. So tables are great for organizing. They're great for organizing, for guess and check, and for finding patterns. Now I'll go ahead and tell you this. Next task, a table is a great option. A graph is a great option. You can do it algebraically as well, but this is a great starting point. What questions do you have before I cover 2 more ideas? Actually, I only want to do 1 more this morning. Stretching, Kelly, or you got a question? Okay. What are your questions? Going once. Going twice. Okay. One last thing, and it's over here. I need us to be very clear on something, because this is an issue that I do see very regularly. It's missing a key detail about multiplication. When I write 3C, anyone know what that actually means? It's what? 3 times C? Yeah? But what does 3 times C mean? What about 3 C's? They're what? Yeah, 3 bottle corks, but what is happening with those bottle corks? And like that's in the context. Huh? So is this the same thing as C times C times C? You say no to me, and why not? So that would be exponents. And so I want to point this out. An exponent is repeated what? So I'm going to be, actually update this. I'll say a whole exponent. I'll explain why in a second. So a whole exponent, that is repeated multiplication, right? All we have is single multiplication, not repeated multiplication, right? So what is that single multiplication indicating? If I were to tell you 3 times 5, what would you tell me that is? 3, or 15, sorry, I don't know why I went to 3, 15. But why is it 15?
5 times 3 is 15.
Yeah, but why is 5 times 3 15?
Because you're adding 5 3 times.
Because I'm taking 5 and I'm adding it 3 times. We forget, and as teachers, to teach this, to remind this, at its core, what is multiplication? Repeated addition. So when I say 3 times C, what do I really mean by that? C plus C plus C. If you see multiplication, I need you to recognize and think about, because it's going to matter a ton for linear functions. When you see multiplication, you need to think about repeated addition. And if you ever see repeated addition, you need to think about multiplication. That is something that, like, there's a whole lot of information on the board, but for what we're about to study, I need you to recognize and be completely aware that if I see multiplication, that is repeated addition, and if I see repeated addition in any way, I'm going to multiply. In a similar way, if I ever see repeated multiplication, that's an exponent. If I see an exponent, that is repeated multiplication. I gave you a graphic organizer for this to use or not to use algebra, the mathematical representations. Make the notes you need to about bottle and cork. I'm going to add some more details with this multiplication and exponents idea. But write down what notes you need to, not just write down the problem, but maybe notes about that substitution method, maybe notes about that elimination method, maybe notes about using a table. By the way, what method did we not, what representation did we not use yet? I kind of used verbal. We talked about it. It starts with a G. Graphical, right? Could we have here? Yes. We'll do that in a later one, okay? So go ahead and do your notes. I'm going to make the notes about addition and multiplication while y'all are working on that. So whatever notes you need to make for your future forgetful self to be able to study off of.
have a job now.
So I wrote some more blue notes over here also about the process of solving equations. Again, I would also make note of using that in the reciprocal to undo. Does anybody need me to leave this up here, or can I start to erase it? By the way, there's also a time that you can ask for clarification on things if you need me to clarify. we'll talk to your group to ask for clarification. Yeah.
I'm also here.
So right here, you see how these things are being added? So, and that's important to notice, right? And someone in here, even though I don't have the multiplication symbol, that's 3 times x squared, x plus x plus x. And so repeated addition versus repeated multiplication is a really important point we're about to go into.
Want me to stop recording?
Sure, we're gonna start back in a second, it's fine. All right.
I just leave it on then.
Yeah, that's clear. Do you understand why I was careful with whole exponents there? Yes. Okay, good. Make sure. Just, yeah.
It's fun watching you ask the questions from the line.
Yeah, it is. I get it. Yeah. Okay. While the last of us are finishing up notes, I do want you to notice something here, for those who already finished. Notice how I said you can make a graph as well? See how I typed my 2 equations in? Anyone know what I could do now to find the weight of the bottle and the cork? Notice I did have to translate to x and y for the calculator. So what could I do now? Yeah, that's doing it algebraically. I'm talking about using the graph.
Always my graph.
Yeah. Huh? Move the line, but I don't want to move the line. Those are the lines. Davis, what do I want to do? What am I going to do on a calculator if I want to do cool crap?
Menu.
Ah, okay, cool. Menu. Anybody see any options now after hitting menu? What am I going to do to that graph? So I already have the graph, so I don't need to enter it. What? I don't need to edit it. I already got the graphs there. Don't I want to analyze that graph somehow? Did anything stick out to you about those equations that kind of shows up right here? Say it again, David. And so remember how we did lower bound and upper bound with z-scores? Lower bound just means lower, or to the left. Upper bound means to the, holy crap. Look at that. Huh. That look familiar? Weight of the bottle and the weight of the cork. So if you can write an equation, or if you can make a graph, that's a really sweet way to do it. What are your questions? Ready for the next little task to play around with mathematical ideas? How'd I get to that? So, remember, just because Belle's asking this, remember if I want to do cool crap, what am I going to hit? Okay? And so I wanted to enter what? I wanted to create a... I wanted to what?
Graph.
I wanted to create a graph, so what allows me to create a graph? Graph entry, right? And notice if you go to graph entry, you can do a function, but a function requires that it's y equals. Because I had x plus y, I didn't have y equals. I could have made it that way. But a relation allows me to type it in any way I want. So notice how I typed in, under relation, x plus y equals 315, and x minus y is equal to 300. And I did have to change the window. If you just type that in, you will not see it right away because the standard window goes from like -10 to 10, and you have to change the window. So don't sweat that right now. I'll help you with it. I do want to get to the next little task. But just being aware that we can do that. So hear me clearly on this, guys. If you're like, hey, I want to use a graph, but I don't know how to use it right now during this next time, ask Mr. Hobby or myself, and we'll be more than happy to show you how to create those graphs. Okay? And you're going to be doing lots with these calculators throughout what we do. So, ready for the next task? Kind of? Not sure? Alright, so let's actually do this. For the next one, Roy and Joel. It's summertime, right? Anybody go to the pool this summer? I definitely went to the pool, right? I actually moved to a new neighborhood. It's got a pool in the neighborhood. It was sweet. My son loves the pool. He has to go to the pool every single day just about. But Roy and Joel don't have that option. They have to go to a pool they have to pay for. And so there's two different options. Option one is you just pay $25 every visit. The other option is that you pay a, was it $100 fee? Hold on, let me check this. I should have this memorized. I've done it a few times. Let's see, $240 fee. Woo! Woo! $240 fee. But it's only $10 a visit. At the end of the summer, they spent the same amount.
Wait, what? Hold on. 25 every visit.
So here's the question for you. How many times did, and also, by the way, I should clarify this. They went the same number of times. So they went to the pool the same number of times. So if they went the same number of times and they paid the same amount at the end, how many times did they go to the pool? We have to think about this mathematically. We're going to have to think about different representations. So if you're not sure, that's okay. Let's think about a way to figure this out. So notice, I think it was Roy chose this option and Joel chose this option. So Roy had to pay $25 every time he went to the pool. But Joel paid $240 up front. He only paid that once, by the way. $240 one time. And then there's only $10 a visit afterwards. So each of his visits was cheaper. And they went to the pool the same number of times, and at the end of the summer, they spent the same amount. So how many times did they go to the pool? Let's get to our vertical surfaces. Let's start playing with it. I want everyone actively engaged. I don't want to have to come over and see somebody standing back not doing anything. We got to learn and grow together.